Assalamu alaikum everyone. Hope you all are having a great day. Let's start with the basic introduction of our team. My name is Amar Iftikhar and my team member is Fizan Beg. And the basic purpose for this presentation is to have a detailed discussion on an important topic in operating system. I know you all must be familiar with this, but we will try to discuss it in detail. Before we finally get on with this, I want you all to imagine a world where the software applications cannot communicate with each other, where information cannot be shared, and where the system cannot collaborate. Obviously, it would be like a chaotic environment and disconnected digital landscape. Fortunately, we have a solution to this problem, which is inter-process communication. So, let's start. What is inter-process communication? Inter-process communication refers to the different process mechanism that enable different process or program to exchange information, synchronize their activities and coordinate their actions in computer system. It allows different processes to communicate and share data regardless of the fact, it is very important point that regardless of the fact that they are on the same machine or distributed over a network. The goal of inter-process communication is to make sure that successful communication occurs between the processes and the desired outcome has been achieved. Because of its benefits, it has become an essential component for an modern day operating system. Here is a figure referring the inter-process communication between different processes. You can see that there are different processes and they are connecting through an IPC mechanism. We will discuss the IPC mechanism afterwards. Process 1 is communicating to process 2 somehow, and process 2 is communicating to process 3. So, hope you understand. Moving forward, now we have seen that processes do communicate. It won't be wrong to ask the question that why processes actually need to communicate. Here are the main reasons of processes to communicate. Number 1, collaboration. Processes often collaborate when they have a same goal. If two processes are going to do the same task, they need to communicate in order to do the work more efficiently. So, efficiency will be achieved ultimately. Number 3, resource sharing. Often we have seen that processes need to share a resource such as file, a device or a database with the other process. So, they need to communicate in order to synchronize their resource. Yes. Now, number 4, interdependency. If the processes are dependent on each other, like for example, there is a parent-child relationship, then they must communicate in order to proceed. And then modularity. Basically, interprocess communication has encouraged modular software design. Different processes and modules are built differently and they will communicate afterwards. Now, there are some types of communication, but we will discuss the main types: direct and indirect communication. Now, what is direct communication? In direct communication, there are the pair of processes that need to communicate. They communicate in a direct way, but they have to explicitly tell the name of the other process in order to send the message. Whereas in indirect communication, they don't have to explicitly tell the other process name or their identifier, but they use a shared message, such as shared mailbox or a shared port or a shared channel. So now these are the IPC approaches. We will discuss the 3 main in the next slide, but here you can see there are a number of IPC approaches through which the processes can communicate. Now, as previously said, these are the 3 main types of inter-process communication. Number 1, shared memory. Number 2, message passing. And number 3, pipes. The choice of IPC mechanism only depends on the specific need of the process. Now, let's discuss shared memory. Shared memory IPC is a technique that allows multiple processes to access the same portion of the memory. Now, but it won't be wrong to ask that what is the benefit of this. Its benefit is that it enables them to share data and to work more efficiently. As it has written that shared memory allows faster communication between the processes. You can see from the figure in this slide that the process, if we see the left figure, process A and process B are communicating with shared memory. They are both are having a same portion of the memory, so they are communicating with each other. Okay, here is a code in C language that demonstrates shared memory in C. Now what this program does, let's discuss. Basically, this is a C program that demonstrates shared memory. The program first generates an key for inter-process communication using the system called ftalk. Then a shared memory is created using a shared memory get system call, which is used to access or create a new shared memory. Now to write data into it, we use the fget system call, which takes input from the user or from a text source. Now to write data into shared memory previously created, we will use another process that will write the data in it. So hope you understand. Now to proceed the presentation, I will call my team member Fazan Beg.
Let's talk about message passing. Message passing is a technique that involves sending messages between processes in an operating system. In message passing IPC, a process sends a message to another process, which then receives and processes the message. Message IPC can be implemented using variety of methods including sockets, pipes, and message queues. This is a figure referring the message sharing between processes. The first process sends the sending process in the message processing module. Type message receiving process. This is a code snippet for a message in C language. Create a message queue using the msgget function and obtain the message queue. Fork a child process using the fork function. Once the message has been received, print it to the standard output using printf function. Remove the message queue using the msgget function in the child process. Now let's talk about pipes. Pipes IPC is a technique that allows two processes to communicate with each other through a unidirectional communication channel. In pipes IPC, one process writes data to the pipe which is then read by the other process. Pipes can be either anonymous or named, with named pipes allowing multiple processes to communicate through a common pipe. This is a figure referring the pipes between the processes. This is a code snippet for creating a named pipe in C language. It first creates a pipe using the pipe function, which creates two file descriptors representing the read and write end of the pipe. Fork a child process using the fork function. In the parent process, close the read end of the pipe using close function on the file descriptor representing the read end. Write a message to a pipe using the write function on the file descriptor representing the write end. In the child process, close the write end of the pipe using the close function on the file descriptor representing the write end. Read the message from the pipe using the read function on the file descriptor representing the read end. Once the message has been read, print it to the standard output using printf. Close the read end of the pipe using close function in the child process. Importance of understanding IPC. IPC is a concept in operating system and plays a critical role in modern computing. Understanding IPC can help developers create more efficient and robust applications that can take advantage of multiple processes and computing resources. Knowledge of IPC is also essential for tasks such as system administration, debugging, and troubleshooting. Conclusion. In inter-process communication is a critical concept in operating system that allows processes to communicate and share data with each other. IPC can be achieved using various techniques such as shared memory, message passing, and pipes, each with its own advantages and limitations. Overall, IPC is a fundamental concept in modern computing through understanding of its essential for anyone working with operating system and computer networks. These are some references and additional resources. Now, thank you.